Hello, Cyprien here from FEA for All, and today I'm showing to you something a bit more advanced than what I usually do in those tutorials, but I'm sure that it will help a lot of people because everyone asks me how do you use your own material behavior law into Salome Maker. So there are several ways that I'm talking about into the article which goes with this video, so go into the description and read all the article if you want all the details. Now in this video here I'm talking about the UMAT way. So UMAT is a subroutine which is actually originally coming from Abacus. So here is an example. So it's written in Fortran. So this is a UMAT subroutine to calculate the linear viscoelastic behavior, and it's coming from the Abacus documentation. So I'll use that to demonstrate how do you actually integrate that into your Codaster model. So as you see, UMAT is quite complex. You have a lot of variables. So this is the header of the subroutine, and all of those variables here are either input or output. Here in this file you have the description. Well, it's in French, unfortunately, but you will find description of what all those variables are on internet. I'll try to put a link in the description also. And basically you have to calculate whatever you need in this subroutine UMAT. So I'm not really describing what this subroutine does in details, because this would take hours to explain the mathematics behind that. So this is just a simple tutorial to show you how do you actually run that with Salome Maker. So now another thing I want to say is that if you want to use this specific law here, linear viscoelastic behavior, it's actually already integrated into Codaster, so you don't actually need to use UMAT. You could run it like that. So that's just to show you how UMAT works. And as an aparté, how do you calculate that with Aster? Well, first you have to use the FIMIS ISO-T line relationship in your stat nonlinear study, and this is a relation which actually describe von Mises ISO. So it's von Mises linear work hardening relation. So, and now if you want to add the viscoplasticity and with that, you have to define in your material parameters the Lemaitre coefficients. So those are coming from those relations here. And if you're interested to know about viscoelastic behavior model in this operator stat nonlinear, you can check this documentation here. And I put all the links inside the article as well. Okay, so now let's go and try to use this in Codaster. Usually I'm showing you everything from the start, but this time the model is slightly more complex, so it would take a lot of time to rebuild this model for you. So I created HDF file that you can start with. So I'll put this file for download in the description as well, or inside the article. So you have to start by opening this with Salome Maker 2018. Okay, now you open that, you should have the mesh which is already inside this, and just click here to open the Aster study module. And now you have different kind of things which are already set up in this model. As I told you, I already did big part of the modeling for this example. And let me describe what it does. So basically the mesh is really simple. It's just a simple plate like that. And the model is axis symmetric model. So it's an axis modelization that is chosen here. Now there is a Defi group which is used to transform the mesh groups available on the model into node groups that were not defined. The material data, so I called this already UMAT because this is one of the first thing I'll have to modify, but for the moment it has only elastic parameters. Alpha, which is the thermal coefficient, and Nu, which is the Poisson's ratio, and E, the Young's modulus. I define a few functions here. So the linst is used for the nonlinear analysis to define the time steps, the load steps, sorry. And then you have those parameters, mu, lambda, and ze. Those are parameters that are used inside the UMAT subroutine. So I need those three parameters as well to define the law. So I'll show you how right after. And you have a formula here, which is actually a function x squared multiplied by inst means instant, so it's the variable name for the time. And you have a load, so the load is simply a blockage of dy on those two node groups. And there is here something a bit more advanced, let's say. It's actually this model it depends on temperature in this UMAT file. So in order to be able to solve this with the nonlinear law, you need to have a temperature field defined on the nodes. So the temperature field, we are getting it from those two functions. So the création means create a field of temperature, basically. So it's, you see that the variable, the field it creates here is temperature, and it is based on the function 1 that is defined, that I just showed to you, the x squared multiplied by time. So it depends on the time and the distance x. And then you have créa résu, which means create a result, and this also comes from this création, and it basically creates a temperature result, and this is defined and associated to your material here. So what we usually do when we define a material is that we define the material here, we just associate it here, but you have all the options here which are not used so much, and this VARC, it means external state variable assignment. So what you can do is you can assign an external variable to your material, and in this case we are assigning a temperature variable to the model because we need it for the model. So now you start to understand why it's difficult to do that in the full video to show you all the steps. So I'll give you this model right away. And after you did all of that, you finally start to solve the problem using stat nonlinear, which is a nonlinear operator. You use a calc-champ in order to add more types of results. Stress, sigma Lno, sigma nö, and type of strain epsilon Elga. And finally we print out the result into a file. Okay, So now, how do I link my model with the UMAT that I have here? So I have my UMAT subroutine ready here. How do I put that into Codaster? Well, the first step is that you will have to compile this into a dynamic library that Codaster will be able to read. So in order to do that, we need to open the shell, but inside the Salome environment. So there are several ways to do that. Maybe the most simple is to go into the Salome maker, and here you have into Tools, Plugins, Salome Shell Session. So click here, and if you wait a bit, it should appear. So sometimes it crashes when I open it like that. I don't know why. Just try again. Okay, in this way it doesn't seem to work, so I'll do it in the other way, which works every time. So open a terminal, and the thing is that if now you try to run Codaster by using asrun, well, you get nothing. It tells you it's not installed. It's because you are not in the right environment. So you need to enter into Salome Maker environment before being able to run Codaster. And by the way, don't do this. Don't do sudo apt install Codaster run. You'll get a very old version of Codaster run, which is really, really old and will not run properly your code. Anyway, so how do we enter into the Salome environment? Well, first of all, you have to find where your Salome Maker is installed. So in my case, it's into Salome, I think, Maker, not this one. I have several install of Salome. Salome Maker. I don't know why it doesn't find it. Okay, let's Salome. Okay, it's here. Should be able to find it. Okay, I entered that, and if you look into this folder, you have two types. You have apply and v2018. So let's enter into the apply, and now you're able to execute Salome. So if you enter just Salome like that, you'll just launch a new Salome session. Now you just add shell, and you see that here it changes the color change. So that's because now we are entered into the Salome environment. So if now I do as run, you see, well, I gave him nothing, so it gives me error. It's normal. I didn't precise what do I want to do, but I'm able to access the as run terminal command, which will be used to launch Codaster from terminal. Okay, now what I have to do is to go inside this folder, so which is on my desktop. So desktop UMAT study. Okay, now that I am inside this folder, my subroutine is called UMAT 001A.22. So if I want to compile it and create my dynamic library, I have to change the name. So I have to call it, let's say, add.f, like that. And once you do that, you can use as run, and you can use a command called make shared. You give it an output, which is the name of the dynamic library, so I'll call it libumat.so, and now we give it the name of your file, umat 001a.22.f, and if you did it correctly, you'll see libumat.so, which will appear here. In case you didn't change the name to .f, you may not see that, you may get an error, so make sure you change the name. Okay, so now we got that. So we have our dynamic library which will be able to interact with Codaster. So now we go back to the model and let's start, let's make a few changes. So once you have that, so the first thing you have to do is open your Defi material, and find the UMAT subroutine here, the UMAT keyword. So you see you have UMAT and UMAT fo. So fo comes for function. So if you use the UMAT one, you'll have to define your coefficients, the values of the different coefficients like that directly. And if you define function like I did here, you have to use umat.fo. So I have to define it like that, lambda, mu, and I have to define 3ze. So don't ask me why, it's simply the UMAT subroutine that I chose has to have 5 coefficients, variables like that, defined into the material. So once you did that, your Defi material is ready. And now we need to go into stat non-linear, and we basically need to define your UMAT file library here. So you have a keyword called comportement. So in French it means behavior. So click here, edit, and in the relation just choose UMAT. Okay. The number of variable here is the number of internal variable of your UMAT subroutine. In this case it's 1. The name of the library here is the path where your lib.so is. The best is to give it absolute path, so you're sure it will be able to find it. So let's check what is the path on my computer. So of course it will be different than yours. So paste it here, and don't forget to add libumat.so. So this is the library, and the name of the routine is UMAT. So you can define like that, or with a sub thing like that here, or just UMAT. It will automatically be added. Okay. So you see that it's pretty easy, because now we are all set up to run that. So just save, and let's try to solve. So you see that already did a try before, and let's run that and see if we are able to find the library. Okay, and it works. So basically, as it works, there's no error message. So I guess that's it. So that was quite a short tutorial in comparison to the other very long tutorials that I made. But the purpose is really to show you how to integrate UMAT, rather than to show you all the process that you might also see in my other videos. If you're interested about how do you actually calculate nonlinear models, I have another video showing how to do the Hertz contact with nonlinear behavior. So you can watch this video, which will show you in detail how to set up a nonlinear study. And well, if you're really starting with Codaster and that's the beginning for you, well, I would suggest you to watch all the more simple tutorials that I made before, where I'm going from the start and showing you everything. Okay, I hope it was useful. In case you still have questions, please just leave them in the comments, and I will try to answer you as much as I can. Okay, so thank you. So if you're on YouTube, you'll probably find the link to the article and the next videos inside the description. Otherwise, you can go on my blog feaforall.com and click in the category open source FEA, and you'll find all the articles I wrote about open source FEA and the previous videos inside this category. So thank you for watching. I hope that you learned a lot and that you will learn a lot using all the videos that I am sharing on my blog. So if you like those videos, please help me to share them with your friends and other engineers. And also, please let me know what you think in the comments. It's always great to have some kind of feedback. And if you have some ideas of things you would like to learn or do with FEA, please also let me know. Thank you for watching again.